Can you give me a brief about you as well, so that we just to have an idea?
Yeah. You are on. My name is Jagan. I'm your Hadoop faculty. It's all about me. I'm certified Cloudera Hadoop developer and administrator. Completely, I have 8 years of total IT experience, and last 2 years on Hadoop, and complete remaining years of experience on 6 years on data warehousing tools like Informatica and Cognos, as well as ETL testing. I worked on various domains like telecom, banking, retail, insurance. Around, I've taken 30 online training batches, more than 200 students as of now. These are about me.
It's nice to hear it. Good.
Yeah. Today we are here to take your demo. This agenda of this demo class is what is Hadoop. I'll tell you what is Hadoop. These are the topics for this demo class agenda. What is Hadoop? Why do we need Hadoop? Nowadays, everyone, wherever you go, if there are two people, IT people are talking, there is a conversion. Like, what is Hadoop? Do we need to learn Hadoop? What exactly it is? Why we need this Hadoop? If we learn this Hadoop, how the growth would be. See, these are the kind of general topics you may, right? And you will see how the growth is. Why do we need this Hadoop? And how Hadoop works, how it is working, and then HDFS architecture. You may know this HDFS, and you can see what is MapReduce. HDFS and MapReduce, these terms may be very new for you. It may not understandable for you at this moment. Please, adjust yourself, and will be explaining you in detail in the next coming slides. And what is cluster? What is Hadoop process? What is Hadoop cluster? And what is Hadoop process? And topology of Hadoop cluster network, distinction of Hadoop framework, prerequisites for Hadoop installation. What are the prerequisites for Hadoop installation? Various Hadoop certifications. What are the certifications available in the market? Who are the providers where we can write certifications? Everything we will see in the next coming slides. Okay.
Sure.
Now, what is Hadoop? Hadoop is an open source framework software. What do you mean by open source? A software which can be downloaded free of cost from the website, and where we can install it for free of cost. That means without any licensing fees. So that is called an open source software. For example, have you ever heard about Ubuntu?
Which one? Sorry.
Ubuntu, Ubuntu. It's a Linux software.
Okay.
So it is an open source software. In the same way, Apache Software Foundation developed this software, Hadoop. It's an open source software. We can download this software from Apache Software Foundation. This is used for distributed processing large sets of data. It is used for distribution processing of large sets of data. What do you mean by large sets of data? What do you mean by distributed processing? Yes, it is used for big data. Big data is nothing but large sets of data. Large sets of data processed in a manner of distributed. What do you mean by distributed processing? What do you mean by large sets of data? For example, you are working in an IT company. Your manager will be there. Manager will be, assigning a task to the team lead, right?
Yeah.
Manager will be assigning tasks to the team lead. If a team lead alone want to do that work, it will take much time, right?
Yeah.
He'll assign work to the resources and he'll make them to work. He'll make them to work. So he'll distributing the work. He's asking resources to work and complete it within the time. So he's nothing but distributed work, distributed processing of large amount of data. Large amount of data. What do you mean by large amount of data? This is a general terminology. If we are looking at this, if we have some thousands of GB data, if we have thousands of GB, thousands of petabytes, thousands of terabytes, we have. For example, if you want to process the data, we need to have some mechanism that we can process efficiently. Otherwise, it will be taking so much of time. The process will be taking some days of time. So our end users will not be waiting that much of time. So there might be a process issues. So that is the reason we need Hadoop. How it is processing large sets of data, you will see in detail. Okay, I think you understand this or not?
Yeah, that time is fine. It is straightforward. I mean, distributed bus. It is there. I mean, it is common term for across all the technologies.
Correct. We will see. Yes, it is common for all the technologies, but it is something different than other technologies, other traditional databases.
Okay.
We will see that how it is different than existing traditional databases. We will see that.
Sure.
Okay. It works across the clusters of computers. It works across the clusters of computers by using simple programming model called MapReduce. MapReduce is nothing but a core component of Hadoop. One is HDFS and another one is MapReduce. These two are core components of Hadoop. We will see that now keep it like this. We will discuss in detail about the MapReduce. What is MapReduce? What is HDFS?
Okay.
Now we were talking about big data, right? Big data, huge amount of data, large amount of data, large sets of data. These are the various terms to call big data. So now, what do you mean by big data? Big data, in the sense, GB is called big data.
Yeah, I mean, we have KB, MB, kilo, and then GB, terabytes and all right, gigabytes. Yeah, those are all big data, large data.
Yeah, KB, bits, bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, zettabytes. Till gigabytes we are able to handle with the existing traditional systems in a efficient manner, right? If we have more than that data, how that data is generating? First of all, if you can see this slide, Google Plus, Facebook, Pinterest, LinkedIn, Twitter, MySpace, YouTube, Yahoo. These are the social media websites, kind of. Okay. Now, just you assume that in the 2006 or 2005 or 2004, how many users are there in the Facebook? How rapidly it was increased? How many people are using this Facebook account daily? Okay, you can see this video popularity growth. Okay, one video is there. Everyone using technology in these days. Everyone using this technology in these days. So if you can see this video, there was a video called something. A song was very popular in these days. That is Gangnam Style.
Yeah.
So everyone, this kind of videos, not only that particular video, these kind of videos, people are, looking at these videos in a YouTube. So they look at videos, they enjoy that videos, and they'll share with their friends, right? Sharing is nothing but generating some data, right? Sharing is nothing but generating some data. When they are sharing, a video will be shared in a video format, as well as there will be some comments for videos that will be in text format. Okay, so when we are commenting on that, our profile pic will be there. That would be in a picture format. So here various kind of data is generating. Various kind of data is generating. It can be video, it can be audio, it can be image, or it can be text. Anything. So these are the things is not able to processed by existing traditional databases. That is the reason we need Hadoop. Okay, that is the reason we need Hadoop. The amount of the data is very high, and the data format, and the existing databases we use structured data. Here we can save any kind of data into the Hadoop. Any kind of data we can load into the Hadoop and we can process it. We will see that in the next slides how we can process that. Okay,
Yeah.
is it clear now?
Yeah. Clear.
Yeah. Next, if you can see this slide, data is growing very faster. Say Facebook example. If you can see the 2004, 2005, 2006, there was not much growth for Facebook, right?
Correct.
From the 2006, 7, 8, 9, 10 till 2010, this graph is about. Till 2010, the growth is like anything. Every year, the users are increasing. The Facebook data is generating like anything. So for this kind of, as we discussed about YouTube, the same way for these kind of data, the existing traditional databases are not supportable as well as not sufficient. That is the reason everyone is looking for other alternatives. Everyone is looking for other alternatives. So here Facebook will be generating same data, kind of videos it will be generated, images, photos we can share in Facebook, videos we can share in Facebook, we can share comments, our status, everything we can do in Facebook. So in the same fashion, every user will be doing that. Each and every user will be doing that. Approximately, as per my understanding, other than uneducated people, each and every person is having Facebook accounts, including farmers. Correct?
Yeah.
If apart from uneducated person, each and every person is having Facebook. So you can expect how much data Facebook may generate in a day. Approximately in a month, 400, 500 petabytes of data is generated. So the existing traditional databases are not sufficient and supportable for this kind of data processing. Okay.
Okay.
You can see need to process petabytes of data every day. The data may be generated by various companies like Google Plus, Facebook, Pinterest, Twitter, LinkedIn, YouTube, MySpace, Yahoo. So the data may be processed by existing traditional systems like Oracle, SQL Server, Teradata, Netezza, Oracle from Oracle Corporation, SQL Server from Microsoft, Teradata from Teradata, Netezza from IBM. These are the databases are able to handle till terabytes of data. Still, terabytes of data may be processed by Teradata and Netezza, but the process is going to be slow. I'll tell you how Hadoop efficiently process terabytes of data. Yes, of course, we may process terabytes of data with the existing traditional softwares or databases. Then there is a scope that in the near future, not near future, it's already existing. So many companies are generating petabytes of data every day, zettabytes of data every day. When they are generating petabytes of data, so how to handle that kind of data? That is the reason people are looking for Hadoop and big data. To handle big data, Hadoop is required. Okay.
Okay.
Next. Now you can see this slide. Facebook. Facebook is generating 300 petabytes of data every month. Google 400 petabytes. eBay 250 petabytes. Twitter 100 petabytes. Picasso 150 petabytes of data it is generating every day. So for these are basic examples, well-known companies. That is the reason I've taken these examples, to make you understand. So existing systems are not supporting for big data. These kind of companies are generating huge amount of data, nothing but big data. So existing process databases are traditional systems not supporting for this kind of data. That is the reason we need Hadoop. Here you can see just before we discussed about structured versus unstructured data, right? So what do you mean by structured data and what do you mean by unstructured data?
The structured data will have a general typical database design, right? We will have rows and columns. I mean columns defined and the data will stored in the row basis.
Yeah, correct. See, we'll be having databases. We design schemas. We create tables.
Parent-child relationships.
Everything in a proper format. It's structured. It's very well structured, so that we can load the data into the databases and we can use it. In case of Hadoop, if you can see, have you ever heard about Aadhaar card in India?
Yeah, right. Recently there that is also they're saying it's huge data.
Yes, Indian guys in Indian government. It's mandatory for every Indian.
Right.
You should have this Aadhaar card. This may be used in various places. Complete various levels of government decisions it will be used.
Yeah.
So while taking this Aadhaar card, they need our biometrics, fingerprints, photos, and our complete information in a data format. Everything they need, right? That would be
correct.
That would be some at least MB of data for one person. Some MB of data will be generating, right? So
correct.
Is this data is able to are we able to store this data in a Oracle table or Teradata table? Are we able to process this data efficiently by using existing traditional systems? No. That is the reason everyone, not only government of India, not only Facebook, not only Google, not only Yahoo, everyone, each and every individual company is looking for Hadoop. What next? What next? I am having this deadline. Yes. Now Facebook is generating some 400 petabytes of data every month. Now Bank of America may generate, an insurance company may generate, Walmart is already generating. So n number of companies are there. They are next there is a deadline. There is a deadline for everyone. They need big data. There is a deadline for everyone. Of course, now see, for example, now my company is able to handle terabytes of data. Yes, I am having some traditional systems. I am able to handle my data, available data. But there is a I have a concern. Yes, next 2 years I am able to handle my, but after 2 years, what should I do? There is a failure expected, right? There is a failure expected after 2 years. What I have to do? So this question, rising for each and every individual top level management. So now. Anyway, these companies are converting for big data. In the near future also, each and every company going to be convert for big data. I think you can understand, right?
Yeah, right.
Okay. So there is a deadline for everyone. There is a deadline. So that is the reason everyone is looking for Hadoop. That is the reason these companies need Hadoop. Okay. If you have any questions, then ask me. Otherwise, we'll go ahead to the next slide.
Yeah, we'll go ahead next slide.
Yeah. See, we can add n number of clusters and n number of nodes to the existing Hadoop framework. We can add n number of clusters and n number of nodes to the existing Hadoop framework. So, for example, for example, this is the Hadoop master machine, and these are the slave machines. These are the slave machines. For example, this a company Walmart will take a company. Walmart is just for an example. At Walmart, are saving this database into 3 different places, 3 different nodes. Now, if Walmart is also, having more amount of data in the next year, what Walmart is supposed to do now? So here this can add n number of nodes like this, and it can be utilized. If one more, can add n number of, can be added to the existing cluster and can be used. How many they want, that many they can add it and they can use it. There is no limit for this. There is no maximum limit for this, but if there is a minimum limit for this. What is that minimum limit? Minimum one node should be there in the network. Got it?
Okay, when you say this, right, it is like it is the database structure, or it is like when you say that just a computer each one.
Sorry, I didn't.
Or like I mean, it is like is it that there is a one master, one server is there, and you will have that multiple individual.
No, it is not kind of server and client. It is not kind of.
Okay.
Each and every machine is going to be active in the process.
Okay. Mm-hmm.
It is not only just database. I'll discuss that in detail in the next time.
Okay.
See, this here I'll tell you. Here, master. Now itself I'll tell you. Job tracker will be there.
Okay.
Job tracker. This master node contains job tracker, and this is the data node. Same, this is also data node. I'll tell you.
Okay.
Data node 1, data node 2, data node 4, 5, 6, 7. Okay.
Okay.
All these data nodes contains separate task trackers.
Okay.
Task trackers. Task tracker 1, task tracker 2, task tracker 3, task tracker 4, task tracker 5, task tracker 6. See.
Okay.
how it process. I'll tell you. For example, you can compare with your existing traditional databases. So now, this is the database which we are processing now. This is the database we have now. We are processing this database into Hadoop, right? This we are processing this database into Hadoop. And now this master node will be taking care of this data, how it needs to be processed into the database. The database is called, the database name itself is called HDFS. Just before we talked about HDFS, right?
Okay.
This is nothing but HDFS. HDFS. These are Hadoop file systems. This is nothing but Hadoop file systems. Okay? Hadoop distributed file systems. How it will be managed in the Hadoop framework. We will see that in detail. Now, just for this moment. This job tracker will be assigning task to the job tracker. Job tracker will be assigning tasks to the task trackers. All the task trackers. So it will, whatever the data it is getting, for example, this data size is some 1, 2, 3, 4, 5, 6, 7. Now 7 petabytes. Okay, this database size is 7 petabytes. 7. Okay. Now, how it is going to be distributed in a Hadoop distributed file systems. Now, first 1 petabyte of data is going to be saved in this area. First petabyte. Okay. Then next, second petabyte. Third. Petabyte. Fourth petabyte. Fifth petabyte. Sixth petabyte. And 7th petabyte. 7th petabyte. Right? Now, if you can see, each and every place, each and every node is having a task tracker. Each and every node is having a task tracker. Try to observe this. Each and every node is having a task tracker. This task tracker responsibility is to take the instructions from the job tracker and execute. It may be writing or it may be reading, whatever. Take the instructions from the job tracker and act accordingly. That is the responsibility of the task trackers. Okay, all the task trackers will be taking the instructions from the job tracker and it will execute them. Whatever the task it may be, it will be taking and it will be executing. Okay, now see, what is the, you can ask me a question. What is the difference between the existing and Hadoop? Existing databases and Hadoop, both are same. Anyway, these are doing similarly. So why we need this Hadoop? Okay, you may have that question, right? So I'll explain you why do we need this. Now, this first bit of I'll show you here. One more example I'll tell you. See, this is the first petabyte of data. Okay, saved in this
Yeah.
area, in the first node, and this is the second petabyte of data. Try to observe here. Don't get confused.
Mm-hmm.
Third
Mm-hmm.
petabyte of data. This is a complete block, but this is the space occupied for first petabyte of data. Okay, complete node. This is a space occupied for fourth. This is space occupied for fifth. Space occupied for sixth. Now this is in this color. This is in green color, and this is in blue color. Some other color. Some other color. Now, all these 7 petabytes of data was loaded in 7 nodes. 7 nodes. Now, there is in Hadoop, there is a concept called replication. Replication of data. While loading the data in the configuration file, we can mention how many times we want to replicate the data in the Hadoop file system. Okay, so if we are replicating the data 3 times, for example, if we are replicating the data 3 times, how it will be, we will see. Now this is the green is available in the first node, right? Now the same way green will be available in the second node as well, third node as well. You can just understand here. Now, the first node contains first petabyte of data. The same second node is also contains the first petabyte of data, and third node is also contains first petabyte of data. Right? Getting me?
Mm-hmm. Yeah.
Now, the second node contains first node contains this data. You can observe here. How many times the data is replicating here? Hello?
See, yeah, I couldn't get it correctly in this one, the same. Yeah. You will have the, initially what I understood is, okay, I'll explain you what I understood so far. Okay.
Mm-hmm.
So you will have that, in other database, you will have the overall, you have the data of 7 petabytes, and you are loading to the Hadoop, and then it is getting a kind of distributed kind of thing to the across the multiple data nodes. Yeah. And each node you have like one terabytes, 1 petabytes, like that. But then
yeah.
Okay, I mean, but one thing I wouldn't understand, like what is the size of the individual data node, and on what basis we can split how many? See, only 1 terabytes only we can store it in individual data node, or something like that. I couldn't get it.
No, it is not like this. For your example, the file may or may not be 7 petabytes, right?
Okay. Yeah, it could be many things. But is there any limitation on the number of data nodes can be created? Is there any?
No. Just before you can see here, as I discussed, n number of nodes.
Okay. There is no limit. Okay.
N number of nodes we can create. Okay. There is no specific limit for nodes.
Okay. Then each node, right? Each node, the size of each node will need to be. Yes, if I understand right, the data actually getting stored at the node, right?
For example, Hadoop runs on a. I'll tell you one more thing here. Hadoop runs on a commodity software, so commodity hardware. Okay, commodity hardware is nothing but a simple uh, sorry, one second. A simple and lowest configuration computer. Lowest configuration computer. So, where we can use the computer as a node, where we can use that computer as a node. For example, if I am having a 2 GB RAM and 50 GB hard disk, 2 GB RAM and 50 GB hard disk, or 1 terabyte of hard disk, or 500 GB of hard disk, it can be anything. It can be anything. So when we are connected to the as a node, our laptop, think from that side. As a node, when we are connected to the Hadoop master node, it will be treated as a node. So complete when a file is coming from the other sources into Hadoop, when a file is coming from other sources into a node, the master node will be taking care of this complete loading process. So if your system is having 500 GB of hard disk, a file is coming from other source as 1 terabyte of file, a single file. So it will be taking some place from your hard disk and some place from my hard disk. I mean,
Okay.
and some other place from some other. So if your part is completely loaded, there is no space from your side. So it will be what is the meaning of that? I have also no place. Some other XYZ also no place. Some XYZ also no place. So only this one is having, this computer is having the place. Only this computer is having the place. There is no space in these other nodes. Does it mean that are we going to stop our process?
No, right. If
These computers are not having the space. It's fully loaded. It's fully loaded. Are we going to stop our process? No.
we should not try.
No. So our mechanism, designed as whatever the data is, coming into the Hadoop distributed file system storage. So it should be replicated 3 times. So as we don't have space in other nodes, so only one node is having space. Still, it will throw an error. There is no space for replications. Why? Why there is no space? You have only 500 GB of space, but the thing is the file is 1 terabyte, and there should be minimum 3 nodes should be available to load the data, because we are replicating the data 3 times. We are replicating the data 3 times. So it will throw an error, and so that time we will add one more node to the existing network, and we'll process that file again.
So basically, right, let's say that, if I have that, the each node, like, let's say that, the 100, let's say that, that's way, like I have the 3 nodes, and each node having like, 100. The incoming data, let's say that 400, right? So you have the 400 bytes data, and you have only and each node have the 100. And when you come to that, how do you split the data? On what basis you will split the data to 100, 200, or 300? You split the data if there are certain logic, so that we'll put it just 100, 200, 300. Then we have that still the 100 more is there, and we need to find there is no space.
It is not like that. It is not like
Okay.
that. While installing this Hadoop on our machines, there is a configuration file. In that configuration file, we have to specify. Okay. We have to specify how many times you have to replicate. That is what you need to specify.
Okay.
Based on your requirement, your importance of that data. you have to specify how many times you have to replicate. So if you are processing again a 300 GB of data, 300 TB of data, again one more file. Let's take 300 TB of data. Okay, 300 TB of data. Now, if see there is only 500. For example, 200 will take 200 TB is available. Okay, 200 TB is available. Now, while installation, you have selected like in the configuration file 3 times replication.
Yeah, the replication, just couldn't get the concept how that works. Okay, maybe you can.
3 times replication. Okay. Now, do you have extra space to replicate the data? It is not like the concept is like you have to maintain this 300 TB data in various places. If one node is going down, for example, now you can ask this. Now this is a 400 TB is available. Okay.
Yeah.
As you said, forget about replication. Forget about this 200 available memory and 200 space, and this replication is also forget. We have not mentioned anything in the replication. We have mentioned only one-time replication. Fine.
Yeah.
Now this is what your question is, right? So now you are able to load this 300 TB data into here. Yes, you can load that 300 TB of data into this node.
Correct.
Now you have loaded this data. For example, unfortunately, if anything happens, okay, this node is down. Now this node is completely down. Are you able to process? Are you able to process the data from this node?
No, you can't do that. Okay.
So we cannot do anything, right?
Yeah, right.
So we can the process wise we can do.
Yeah.
However we want, we can customize and we can do. But the thing is, whenever this node is down, the system is down because of network failure, because of virus attack, because of n number of reasons. It may be any reason. So if this node is down, what would be the next process? Are we going to stop our process? No, it should not happen. Basically, that is the reason Hadoop came into the picture. Because of any reason, the process is not going to be stopped. The process will be continued.
When you say that you have the configuration file, you will configure it, right? When you say that how many replication you will do that, you will mention it, or like what is the size on each, how many replication as well as what is the size in
internally,
each replication.
Internally, how it works, we cannot define the size. We cannot define the size. If you are processing, if you are processing 300 TB of data, okay. You have mentioned 3 times replication.
Yeah, right.
If you are one more thing. If you are processing 300 TB of data, okay. So if you have mentioned 3 times replication, okay, that is going to be loaded on 3 nodes, right?
Okay, it will be stored in 3 nodes. Okay, it will not. Okay.
It will automatically calculates and it will be loading in a 1 node 100 terabyte, right? And
okay. When you say that 3, I mean the replication nothing but 3 nodes, is it?
Correct.
Okay. Fine. Okay. Fine.
And the replication.
So based on the number of nodes, it will split it.
Based on the number of nodes only it will split it.
Okay.
Replication is nothing but how many times it should be. It doesn't mean that the same data keeping in the same node 3 times. That doesn't mean, because the node is going to, sometimes the node may go down. So that time that data cannot be processed. how many times
Okay.
you can replicate it?
Okay, one more question. Let's say that you have only 3 nodes, okay, and you got the 300 megabytes, and you have the 3 replication, and then you will have the data 100 in the 3 nodes.
Correct.
If I have that, but each node has the capacity of 400. We can say that each have the 200 capacity. So overall we have the 600 thing, but I am sending just 300 data. So it will be split into 3 nodes, 100, 100, 100.
Obviously.
And if I give that another 300 as an input to the Hadoop, then what it does is it will put that the 100, 100, 100 to 3 nodes, correct?
Correct.
In the third one, I mean, if I am trying to insert anything beyond the data, but it will come there, it will not, it can't triplicate it because we don't have the enough space in either of them, right?
Yes.
But let's say that one of the node has that 300 bytes, others have that 200. You have the data for the third times you will have that 100 bytes of space to store it, but the second and third you don't have it. So that time you will get an error saying that in the second node there is no data or something like that.
It will not load into first node, second node as well. Before that only it will throw you an error. There is no space.
Oh, okay. Okay, it will find before it is
yes, because
storing itself.
Because complete complete data node information will be having name node. The complete name master node contains complete information about the data nodes, slave nodes. Okay. So it is the master node itself complete having complete hold on the data nodes. So it will be checking and it will be throwing an error.
Okay. Now let's say that see, I have there I mean, one project is there. Okay, let's say whatever it may be. In the real-time environment, let's say that on anything in any branch, if you go to the computer, any branch of any bank, so there will have that let's say the 4 system are there. Then how you apply your Hadoop there? I mean, you will have the one more system there as a master node, and you will have that individual computer assigned as a node, or how do you do that, or how you set up generally?
It is not like that. It is not like that. In a Hadoop architecture, master node will be one.
Okay. Only one system or computer?
Sorry?
It will be just as one system, one computer you can call it, right?
Yes, it's a computer. Yes, it's a computer. Okay. Master node will be one. The architectural, this is the architectural concept. Master node will be only one.
Okay.
Data nodes can be anything.
Okay.
Job tracker will be only one. And task trackers can be n number of task trackers we can have.
Okay. In master node, people actually won't work, and the data node people will work, or data node also it is just a data storage kind of like it will be there and no one can work. How that works?
Yes. Yes. Data node will be taking care of data. It contains task trackers. Task trackers will be task trackers.
Yeah. Okay.
Task trackers.
What I understood. Sorry.
You can.
I understand. Yeah. I understand. Okay. These are individual node, right? It will have the data, right? It is just only the hard disk it will have. Is it right? It will have the hard disk and it will be stored in somewhere. And there's no what I'm just trying to see, like trying to see how that individual how it is when you are in a real time, how it actually works.
Yes, so, here I tell you. If a user is sending a request, to read the data, to write the data, whatever it may be,
okay.
That will be, first of all, that job will be coming to the job tracker. Okay. So the job tracker is nothing but a team lead. Okay. The team lead will be distributing the tasks to the each and every resource. In the same fashion, job tracker is going to distribute the task for each and every task tracker.
Yeah, then ultimately all of them are nodes also a server and master also a server, right? You will write a program or code so that you will pass your instruction to the master, and the master will pass the instruction to that.
That is what here happening. That is what here happening. If you are taking normal traditional database, Here,
Okay.
all together, yes, here, that is there also the same fashion. All together,
Okay.
we can save the data.
Okay.
But you can see, you cannot process the data in this level, in the node level.
Mm.
You cannot process the data in the node level. So the data will be recollected by the master machine and the process will be happening there. Here, the process is happening here. The result of the process is going to be sent here and it will consolidate and it will give you the output.
Okay. The actual processing happens at the master. The data node just will have the data actual storage, but all the process will happen is at the master node. That's what you're saying, right?
No, it is not like that again. It is not like that again. The task tracker will be executing the task in the data node level.
Oh, okay.
The task will be executing the task at the data node level and result of that will be sending to the job tracker.
Okay.
Job tracker. For example, a task will be assigned for these three. A task will be assigned these three. These three, a new task is assigned now. Okay. For these three, a new task is assigned now. But there will be a heart beating time. There will be a heart beating time. You can say it as heart beating time. By this only we can identify the cluster health. We can identify the cluster health. Cluster health is nothing but node health. Okay. So when this heart beating time is good, for example, a task is assigned for this. One second, let me. These three, a task is assigned. Now, they are, first one will be when the task is assigned these three nodes, which one will be responding first? Whatever the nearest node or whomever it may be. When you ping, if you can see here, CMD. So the server is responding first. Task tracker will be taking the task. Okay. The server is responding first. That server is going to be taking the task of the job tracker. Whatever the task is assigned from the job tracker, that will be taken care by this. So the remaining two will be aborted. The remaining two will be aborted, and this will be continuing. For example, the heart beating time we have defined as 10 minutes. Just you try to understand. Heart beating time is 10 minutes. Heart beating time is 10 minutes. Now, each and every 10 minutes it should respond to the job tracker. Each and every 10 minutes it should respond to the job tracker. It may the task may complete in 1 hour, whatever it may be, 1 hour or 1.5 hour, whatever it may be. We have defined the heart beating time as 10 minutes. Each and every time, the node should respond to the master. Every 10 minutes it should send this report, status report to the master. Okay, so now just for an example, now 10 minutes happened. Now job started, 10 minutes happened. It is not responding to the master machine. What does it mean?
It is so busy or so much data or something like that?
No, at any cost, whatever it may be. We are not human beings. This is not a human being. As we are defined, it should respond, right?
Yeah.
It should respond. So if it is not responding in 10 minutes, in the 10th minute, what does it mean? That means I can understand that there is some problem with the data node level, so that it is not responding.
Okay.
Right. So immediately, what the job tracker is going to do? Job tracker will be assigning the same work to the other node. Immediately, it will not wait for 11th minute, 15th minute or something like that. It will be assigning the same task to the other node. Before that, what it will check? before that what it will check in real time. For example, in general example, if you are the manager, under you a team lead is working. Okay, you have assigned a work to the team lead and he given that work. That work is nothing but Oracle work. Oracle work. He assigned that Oracle work to the Oracle developer, and team leader is asked, boss, at the end of the day, you have to do this work. Now, team lead is asked him, by the afternoon, you have to send me the status, and evening, you have to consolidate the status and you have to send it to me. And okay, he said okay. Now, by the afternoon, he is not responding, and he didn't send any mail or information or status. Now, what team lead will be doing? Team lead cannot wait for the first resource, information. Okay.
So whatever the data, yeah.
Till after
whatever the, yeah.
Till afternoon he will be waiting. After that he will not be waiting. So immediately what exactly do? He'll assign that same task to the other person. But you have to do.
Yeah.
So before that, what he need to check whether that person, the new person, knows Oracle or not. That is the responsibility of team lead. If you don't know if you don't know Oracle, or that guy is going to complete that work?
Yeah, that is
not possible. So in the same fashion, here also the data node, the master node is going to take care about the data, where it is replicated, where it is available. The complete information will be having at the master node level. So
okay,
it will be checking where the data is available. So it will be pinging that node and it will be assigning this task to that particular next node. So now the green is available here. The green is available here and the green is available here also. So it will be assigning immediately next task to this. Sorry. Immediately it will be assigning next task to this. Right? So after 11th minute, the first node responded. After 11th minute, the first node, this one, responded. Then what exactly the master node is going to do? After 11th minute, this node responded. Now, in this case, what exactly this master node is going to do? So, in this case, it is responded and complete. It was given the status like 50% completed. The task 50% completed. Sir, are you getting me?
Yeah, I got it now. Yeah.
So 11 minutes after 11, we have defined as 10 minutes, but it is responded at 11th minute, saying that 50% of the job completed. So instantly, by the time it get the result from the name node, from the first name node, the master node is going to abort this process. Whatever the process, it is happening at the second node level. This process is going to be aborted. This process is going to aborted as the first node responded and the percentage of work 50% completed. That is the reason it's going to be abort this. Okay. Otherwise, by the 11th minute, if second node responds, for example, if the first node responding at 22nd minute, okay, and first node completed 50% of task, 50% of task, and second node is also responded at the same time. It was completed. Second node responded at the same time, and it was updated the status like 75%. Same 22nd minute, updated 75% of task. completed. So which process is going to be aborted?
The first one will be.
Correct. First one will be aborted. This complete, mechanism will be taken care by the job tracker and the master node. Master node against master node. Master node contains job tracker. It will be taking care of these things.
So as a developer, we need to define the rules, something like that, in that, or it is a
Correct.
default for default.
Yes, correct. This process, there is a configuration file, so we have to define some. It is very simple. It is very simple.
Okay.
Don't worry about that. I'll show you.
Sure.
It's very simple, where we can define everything and where we can load the data in a proper manner, where we can
Okay.
process complete set of big data. And there is a question. There is a question called, if forget about data nodes. Data node fails, another backup data node is there, we can process it.
Yeah.
If master node fails, what will happen? If you can ask me a question like, if master node fails, there might be a chance the master node also can go down.
Yeah, right.
So what will happen?
Do you have any backup server or something backup?
Yes, yes, we'll be having a backup node. Backup node for a master node. Backup node for master node. If, for example, in a school, principal will be there. If the principal is not there, vice principal is there. That means he is not going to become as the principal. He cannot sign. He cannot sign on the. He will not be having complete authority. But
all the responsibility. Yeah.
But he will be taking care of the principal responsibilities until he is available. Until he will be back. Okay. By the time he is coming, so he will be taking care of these. Backup node will be taking care of master node responsibilities. I'll tell you, there is some concepts are there in this master node and backup node. What are the responsibilities it will take? What are the responsibilities it is not going to take? For example, when a user is retrieving the data from the data nodes, yes, master node 100% supports, and when the master node fails, the data backup node also 100% supports to process the data from the data nodes. In the same time, when the master node fails, another file is coming from another area. Another file is coming from another area. So what we have to do at that time? What is going to be happen exactly in Hadoop systems? Is it going to be processed or not? If processed, how will it get processed? If not, how? What to do? What next? These are the questions we have. So these things, this master node fails, backup node will be having read-only permissions. So this reading is okay, but writing, this data has to go there first. Getting me, sir?
Yeah.
The data is going here first, right?
Yeah.
From here to whatever, next here to, it should go here and write it, and here write it, and here write it, whatever. Right, sir? Here write it.
Yeah.
Now, this is not having privileges to write. This file, this backup node is not having the privileges to write this data into the data nodes. What it will do? It will update some temporary files. It will update some temporary files. These are the updates. For example, principal will be telling vice principal that, boss, whenever I am not available, you see, whatever I am doing in my register, don't touch my register. You just maintain your own register for temporary purpose, and when I come back, you just let me know all the updates. I'll be making updates in my register. In the same fashion, this will be maintaining some temporary files, and the files, by the time master node, baked up, or it's up and running. So it will identify automatically what are the temporary files available for me when I'm not working. So it will take that and it will execute it.
Okay, so the backup server will have an access to that nodes, but on the job tracker, alone, it may not have. It will have only the read access. That's right.
No,
That's what you are.
backup node also having the job tracker. Without job tracker, nothing we cannot do. So master node is also,
But it doesn't have access to the master node job tracker. That's what you're saying.
correct.
Okay.
It will be having access, but it will not be having permissions. A user can read the data. For example, in Oracle, you can see that, you can observe that. If you don't have write permissions, read only permissions.
Yeah, right. Okay.
So you can read the data, but you cannot write the data.
Yeah.
So it will hold the work and it will wait until the master node is up.
Okay.
Okay. Any doubts, sir, as of now?
It's good. But overall, right, if I understood right, the Hadoop is nothing but a database like any other database, and but it is different than the structure-wise or something like that.
Yes, sir. Structure-wise, it is completely.
But it is a database, right? Hadoop is nothing but a database.
No, sir. We cannot say that. Hadoop is not a database. It is a framework.
Okay. It is a.
It is a framework. It is a database plus process.
Okay. Okay. Just like let's say that the people sub package, right? So that has it has own character, like they have the predefined or something like that. But it will go for again the database. It will go for some other backend. That is a different thing. But here you will have everything.
Yes, sir.
Right.
Yes. Here we have, it's a framework, sir. We have n number of tools on top of Hadoop. We can make, we can generate reports. We can do so many things on top of Hadoop. The complete core Hadoop is nothing but HDFS and MapReduce. We'll discuss in the next class what exactly HDFS architecture, what exactly MapReduce, how it internally working together, how it is processing efficiently. So what is the main reason behind that? Hadoop is getting popular. Okay. As of now, any doubts, sir? Any doubts?
Okay, at this point, whatever you explained, it is good, and just to need to know this level, like I used to hear like the Hadoop is. I'm asking about the overall general perspective. Like somebody was saying like Hadoop is it is a vast area, like Java. You have so many things are there, so it is not very easily can learn. Is it that true? Also that
sir, sir, first of all, you can ask them one question. Have you learned Hadoop, or have you done any research on Hadoop? You can just simply ask one question.
Whoever said it, they didn't learn, that's for sure. But they hear from somebody, or I don't know how they hear it. But just my.
Sir, one question, one thing I'll tell you. Before working on Hadoop, I was working on